Okay, so let me add up the demonstration of the chi-square test using two nominal variables and the mixture of the variables, and possibly in next video the ordinal and ordinal variable with the recoding process by the coding skill. So the race and marital variable. So it's pretty clear that the race, the white, African American, and others is the nominal variable. The marital is as well the nominal variable. So we are using the lambda as I mentioned in the previous lecture. So we will be using the chi-square lambda in this data. So going to the analyze, going to the descriptive statistics and cross tabulation. So changing the variable names and alphabetically. So always this part, the column will be independent variable and the row will be dependent variable. So the column was the race variable. So moving the column, and the marital status is the row. Okay, statistics. So using the chi-square, clicking the chi-square, and we are using lambda, right? Chi-square lambda because we have two nominal variables. So cell the column percentages as we did in the cross tabulation. Okay, so other than that, maybe we don't need to check others, and okay. So this is Mac version 2000. I don't know. This is the Mac version SPSS program 27. So it might be a little bit different from your program in the public computer lab. So marital status and race of the respondent 2,346 cases. So based on this column, the column is the independent variable and the rows are dependent variable. Degrees of freedom is 8 because, so 3 columns, 3 minus 1, okay, 2, 5 minus 1 is 4. So 2 multiplied by 4 will be 8. So we can check the table later, but we can find that the Pearson chi-square is 110. And the statistical significance is, the p-value is below 0.05, which means there is a statistically significant association between the independent variable and dependent variable, which is the race and marital status. So we are using the directional measure, and I mentioned that there is no directional measure between those two nominal variables because there is no increasing or decreasing order. But anyway, the marital status is the lambda value is 0.059, and this is statistically significant different from 0. Okay, so we are not using any sign or something, but we can come back to the table I showed in the lecture slide as where are you? Okay, here. So 0.59. Okay, so it seems the format is a little bit different. 0.059 will be very weak. It's a weak association because it's around or below, around this range of the part. So the lambda, for the lambda, there is no directional measure, so we cannot say there is positive or negative relationship. Okay, so next example. The degree is ordinal variable because it is coded as less than high school, the lowest level of education in that variable. The high school diploma and the associate degree and bachelor's degree or the BA or any kind of the university degree, bachelor's degree and the graduate degree and others. So that will be ordinal variable, and this is the marital variable is nominal variable. So in this case, we are using on the gamma because the mixture of the variables, I told you that we are using where is it? So the mixture of the nominal and ordinal variable, we are using gamma, but we are not considering the direction of the relationship. So again, let's go to the another tab, analyze, descriptive statistics, cross tabulation, okay, reset. Oh no, I thought it was changed. So the degree variable is column because this is the independent variable. Marital status is in the row. statistics, chi-square, but this time the gamma, because there is one ordinal variable. The cells always the column percentage, because we want to see the column differentials of the dependent variable. Okay. So 2,346 cases, not very important in this part. Now instead of checking the total size of the samples, and based on the level of education, there are some variations of the meritorious status. 75 as the Pearson chi-square value, and the p-value or the statistical significance is below 0.05, which means there is statistically significant association between the education and meritorious status. So ordinal and ordinal, this is gamma, but as one variable is nominal variable, it is not meaningful to measure the direction, but the magnitude of the relationship is very important here. So the absolute value 0.157 is 157 is between the moderate association, the range of the moderate association. So we can check that there is moderate association between the degree, the level of education measured by degree, and the meritorious status measured by the meritorious status. So this is the demonstration of the analysis of the chi-square. So when you have two ordinal variables, in my previous lecture, I mentioned that reverse coding is required. So based on this criteria of the health variable, to make the larger number as the more positive, healthier, stronger, better variable, we will need to use recoding process. So you may or you may not remember, but you can go to the edit, data, scale recode. Where is the recoding into different variables? Let me double check. Transform, recoding into different variables. Okay. Oh, one moment, please. Thank you. Sorry about that. Options. Okay. Data, variables. In general, display names and sort alphabetically the output, name and labels, and maybe labels. Okay. Recording different variables. Okay. So health condition is there. Health condition. So variable information is coded as 1 is the smallest number, 4 is poor health condition. So this is not very good way of coding for our analysis. So we will change the larger or the bigger number as the better health condition. So we'll say health, the recorded health condition. In the label, you would add some explanation you can remember, or you can recall your memory later. So recorded health variable would be enough here. And then we change old and new values. So 1, 2, 3, 4. 1 will be 4, 2 will be 3, 3 will be 2, 4 will be 1. So I will go here. So 4 will be 1, 3 will be 2, 2 will be 3, 1 will be 4. Okay? And continue. And okay. Then, okay, so we will come back to the main data. Okay, here it is. So, oh, no, sorry about that. I need to change the variable view. Where are you? Okay, so going back, the Lee health variable, the descriptive statistics. So if we do not provide the labels, it just show 1, 2, 3, 4 without any information. So we will need to go the values. So on this table, so 1 is poor, 2 is fair, 3 is good, 4 is excellent. So I hope I can remember everything. 1 is poor, right? 2 is fair. 3 is good. 4 is excellent. Okay, continue. Then we can see the names are briefly added here. Okay, so now the larger number, the 4 is excellent, 1 is poor. So now we have the very aligned and very consistent direction of the coding of the variable and the meaning of the variable. So coming back on the degree and as well, degree is also coded as the higher number is the higher degree. So let's go analyze. So let's suppose that we are using simulation. Let me double check. Okay, degree and our health condition. So the degree is the column because this is the independent variable. Lee health condition is dependent variable. Statistics, we are using chi-square gamma. Okay, the cell is the column percentage. And okay. So we have that. So 1,569 cases. It seems there is something, some missing or the inapplicable cases. So that was why the total sample size was decreased. Oh, maybe the poor health condition. Maybe there is very small number of the poor health condition. So in any case, the pure chi-square is over 100, and this is statistically significant. So we can say that you will reject the null hypothesis that there is no association. So their level of degree and their health condition is statistically significantly associated. Then how about the strength of the relationship? 0.326. 0.236. No, I forgot. Sorry about that. 326. 326 is the evidence of the strong association. So you would say there is a strong association and the direction is positive. So there is a strong positive association between their education and their self-rated health condition. So by using those examples, you can use that. So the recode and the types of the chi-squares based on the level of measurement, you can decide. And in case your two variables, I mean your independent and dependent variables are all categorical variables, the chi-square test will be a good way. But anyway, we will learn the regression and the correlation in the later part of the semester. So that will be also very, very entertainable and very, very useful for your research paper and your direction of the research paper. Alright, thank you very much and see you in next video.